Hi, I'm Cooper-Macbeth, and welcome to my lab, dreamrealizations.org. I'm just going to give you a quick tour, letting you know the exciting things that are going on here, and hopefully point you just to some other videos that we're creating to fill in some of the gaps and the details that you may be wishing to know. Okay, the first stop is the web page of itonlytakesone.org. Here there's a flash program to help you understand what subquanting is and that you can instantly recognize large quantities of numbers. It's very exciting. Please click at itonlytakesone.org, and that is the symbol 1. This material has been covered in 5th grade, 8th grade, and even in 11th and 12th grade as we validate the process that almost every person we've tested has this visual instinct to see large quantities. Here we see a student actually exercising the program at itonlytakesone.org. And over here we see the base number sheets being used with manipulatives, which are little cubes that the students arrange and then determine if they can see the quantity. Virtually in Second Life, I've created that base sheet here, and we've dumped a bunch of cubes onto it. And here we've arranged the cubes, and with a little practice on that, itonlytakesone.org, you would learn to recognize that this is the quantity 84. And in base 10, you can actually call it 84, as the label for the pattern and the quantity are identical in base 10. But not only is recognizing the quantity important, but also learning to name the different pieces. This is a little device we call the right hand, and it's used to help learn the names of devices. It's a binary counting device. If I just click on add one thing at a time, you can see that we're 3, 4, 5, 6, 7. I'll go ahead and add 8 more quickly, and then just go add 16 more. So here we're looking at the same thing of quantities and able to recognize them real quick. But this device is mostly used to learn how to name things three-dimensionally. Now we're only looking at one aspect of the surface. So in that middle position, we call that a square because that is the square digit. It's the second digit over. Normally it's 100, so you have 2 zeros and a 1, and that would be 10 squared. The one to the left of that, we're used to 1,000, but in this case it's 2 cubed, and so we see our cube shape, and we learn how to name the others. And so if you look at our section on naming the objects, that would be very beneficial. Let me go ahead and turn this one off, turn the 3D off, and I'll clear it for next time. And as the students learn how to visualize something, you hopefully get this. In fact, we almost always get that. Wow, I can see it. It's just unbelievable that they can see what they're looking at. They get very excited about this. And in fact, as they walk around the room, they can instantly recognize it. There is a presentation that I will cover on the number sense, one of the best research documents I've found, talking about how subquant could possibly work and how come we missed it for so long. The next section here that I cover is the meta pattern, and this lays the foundation for solving polynomials very quick. Here we see the meta pattern 1, 0, 1, and in all these bases it's all 1, 0, 1. After the meta patterns, we actually focus in on larger meta patterns, and here we have the meta pattern 2, 3, 4. I'll zoom in on base 9. You should be able to see that. And then when we look at this in a spreadsheet, we actually learn that we can use differences and derive the polynomial 2x squared plus 3x plus 4, which is actually what we were seeing back on the other sheet. We have many other exciting things in the lab to see, and I just wanted to thank you for coming in